Hello guys, welcome back to my channel. In this video we want to discuss geometric progression. So at the end of this lesson you should be able to define geometric progression, you should be able to find the common ratio of a geometric progression, you should be able to find the nth term of a geometric progression, and you should be able to find the sum of the nth term of a geometric progression, and you should be able to find the sum to infinity of a geometric progression. So I will write it as GP, short for as GP, guys. So we'll start from GP itself. Definition. Geometric progression is also known as exponential sequence, okay, because they are sequences that involves multiplication and division, while arithmetic progression involves addition and subtraction. So this is also known as exponential sequence. A GP is a sequence that has a common ratios between them. A GP is a sequence that has a common ratio between them, okay, between each term. Say each term, between each term, okay. So for example, e.g., take a look at this sequence: 3, 6, 12, 12, 4, and then it's an infinite sequence, okay. If you divide the second by the first, you have 2. If you divide the third by the second, still have 2. If you divide the fourth by the third, you have 2. Okay, so therefore the difference between the terms of this sequence is 2, and it is obtained by division, dividing the next term by the previous term. Okay, so this is a GP, a geometric progression, and the common ratio is 2. Okay, so that means if you multiply 3 times 2, you have 6. 6 times 2, you have 12. 12 times 2, you have 24. Okay, 24. So that is that for that. Another example: 2 minus 6 minus 18 minus 54, and so on. So the first term here is 2. So if we want to obtain the common ratio, we divide this minus 6 into 2 will give us minus 3, minus 18 into minus 6, that will give us minus 18 divided by minus 6 will give us 3, okay, and minus 54 divided by minus 18 will give us 3. Okay, so I think there's something wrong here. This is supposed to be plus, and this is minus. Yeah, so in you have minus 3, this is plus, take this as plus, so you can have minus. So the common difference between the common ratio, because the ratio is obtained by division, the common ratio is minus 3. So in other words, if you multiply 2 by minus 3, you have minus 6. Minus 6 times minus 3, you have plus 18. Plus 18 times minus 3, you have minus 54. So it is obtained by multiplying the previous term by minus 3. So the common ratio is minus 3. Okay, so here this is how to generate the common ratio. And the first term, remember the first term, we normally call it U1, which is A. Okay, so the second term will be U2, which is AR. Okay, of course, and the third term is U3, which will be AR times R, which is AR squared. Okay, and of course the nth term from this, the nth term will be UN. If you follow the pattern here, this is UN minus 1 into A times R raised to power n minus 1, because u3 is ar squared, which is 3 minus 1, so un will be arn minus 1. Okay, and this is the formula for calculating the nth term of a GP. So that is the formula for calculating the nth term of a GP. And remember, if the sequence is finite, if the sequence is finite, so we have the un become the last term, okay, last term, which is called L. So L is also equal to AR raised to power n minus 1. So this is how to generate, this is the formula for the nth term, and this is how to generate the nth term. Now we'll move on to examples. Example 1. Show that the sequence 1, 3, 9, 27 is geometric. So we'll start with A. For A, we have the sequence is 1, 3, 9, 27. Okay, we can find the common ratio. Common ratio R is 3/1, which is 3. Okay, and of course ratio is also equals to 9/3, which is 3. So therefore the common ratio is 3. Okay, and the first term A is 1, the second term AR is 3, and AR squared, the third term, is 9. So of course the sequence is a GP, is geometric with common ratio with common ratio 3. B. Find the general term un. So remember the formula for the general term, AR raised to power n minus 1. So ratio is 3, A is 1, so we can substitute it into the general term. We have 1 times 3 raised to power n minus 1, so therefore un equals to 3 raised to power n minus 1. That is the general term. And C, find the 10th term of the sequence. So we can find for C, 10th term, when n equals to 10, just substitute into the general form. U10 equals to 3 raised to power 10 minus 1, which is 3 raised to power 9. Okay, you can use your calculator to check for 3 raised to power 9. Well, let's check, calculate for 3 raised to power 9. Raised to power 9. Raised to power 9 is 19,683. 19,683. So that is the 10th term. And then we're done with our question. Question 2. Show that the sequence is geometric. A. We have 16 minus 4, 1 minus 0.25, and then it is infinite. So to find the common ratio, we divide the second by the first, which is minus 1/4. Okay, yeah. Try for the third and the second, still minus 1/4. So therefore R equals to minus 1/4, and the first term is 16. Okay, the second term AR equals to 16 times minus 1 over 4, which is minus 4. Okay, so therefore the sequence is geometric. Is geometric with common ratio. With common ratio minus 1 over 4. B. Find the 8th term as a decimal. Okay, so the formula for the general term is AR raised to power n minus 1, and of course the first term is 16 and the common ratio is minus 1 over 4. So if we substitute, now we are looking for 8th term, n equals to 8. So if you substitute that, we have u8 equal to 16 times minus 1 over 4, okay, raised to power 8 minus 1, and that will give us 16 times minus 1 over 4 raised to power 7. Okay, remember we are asked to give our answer as a decimal, so 1 over 4 can be written as 0.25. I think, yeah, 1 over 4 is 0.25, okay, raised to power 7. And we can use calculator here. Minus 0.25 raised to power 7, 0.25 raised to power 7 will give us as a decimal, this will give us 0.000061,035 and 16. So multiply by 16. 0.25 raised to power 7 equal to, so we can have answer times 16 times 16, which is times 16, we have 0.00976,562 and then 5. So we can give our answer in standard form, though. 977 times 10 raised to power 1, 2, 3, 4 minus 4 to 2 decimal places. Remember there's minus here. There's a minus here. So the answer is minus 9.77 times 10 raised to power minus 4 to 2 decimal places, or to 3 significant figure, and in standard form. Example 3. Find the general term un of the geometric sequence which has this term. So for A, we have u3 equals to 16, u4 equals to 48. So we are looking for un. Un, of course, is AR raised to power n minus 1. So u3 can also be written as AR squared. u4 can be written as AR cubed. Okay, so AR squared equals to 16, call this equation 1. AR cubed equals to 48, call this equation 2. Now if we divide equation 2 by 1, dividing equation 2 by 1, we have AR cubed over AR squared equals to 48 over 16, which is here we'll have just 1 R, 16 here, 16 here, 3. So R equals to 3. And then we are looking for the general term, so we need to find A. So we can use equation 1 to find A. AR squared equals to 16. Substitute 3. We have A times 3 squared equals to 16. So A equals to 16 divided by 9. And then we can find our UN now, which is AR raised to the power n minus 1. So which is 16 over 9 multiplied by 3 raised to the power n minus 1. So this is 16 over 9 times 3 raised to the power n minus 1, which is of course 16 over 9 multiplied by 3 raised to the power n multiplied by 3 raised to the power minus 1, which is 16 over 9 multiplied by 2 raised to the power n all over 3. Okay, of course, which is oh, let's not do it that way. I'll write it in another form, better form, I think. So 9 can be written as 2 raised to the power minus 2 times 2 raised to the power n minus 1. So if we add the powers, we have 2 raised to the power n minus 1 minus 2, which is 16 into 3 raised to the power n minus 3. Okay, yeah. So this is the formula for the general term of the sequence A. For B, U3 equals to 32 and U6 is minus 4. U3 is 32 and U6 is minus 4. U6 is minus 4. So remember the general formula, AR raised to the power n minus 1. So of course the formula for U3 will be AR squared, and for U6 we'll have AR5, that's minus 1. So AR squared equals to 32 and AR5 equals to minus 4. Let's call this equation 1, equation 2. Then we can divide equation 2 by equation 1. Then we have AR5 all over AR squared equals to minus 4 over 32. So this will give us R cubed equals to minus 1 over 8. Okay, and this R cubed can be rewritten as, anyway, there's a minus there, because anyway, so it will give us a kind of complex answer. This is minus into 1 over 2, minus 1 over 2 raised to power 3. Okay, so if we take the cube root of both sides, equals to cube root of minus 1 over 2 raised to power 3. So that will give us what we are looking for, cube roots. So we have R equals to minus 1 over 2. That is the common ratio. And then from formula 1 we can generate the first term. So remember formula 1 is AR squared equals to 32. So A into minus 1 over 2 squared equals to 32. So A times 1 over 4 equals to 32. Cross multiply, we have 32 times 4. So A equals to 8, 128. So we can now substitute into UN to get what we need. So UN is AR raised to the power n minus 1, and of course A is 128 and R is minus 1 over 2. So substituting into that, we have 128 multiplied by minus 1 over 2 raised to the power n minus 1, which is 128, okay, can be written as minus 2 raised to power minus 1 raised to power n minus 1, which is 128, of course, is 2 raised to power 7 times minus 2 raised to power minus n plus 1. Okay, so and of course this can be written as 2 raised to minus 2. Okay, so I don't know how we can simplify that, but I think we can. I think we can, or we should just leave our answers like that. So we can leave our answer in this form, of course. N minus 1. So let's leave our answers this way. So un equals to 128 into minus 1 over 2 raised to power n minus 1. And that is the nth term of the sequence. A geometric sequence has a general term un with u3 equals to 48, u7 equals to 3. Find u12. Okay, now solution. The general term of this sequence is un by the formula ar raised to power n minus 1. Then u3 equal to ar squared and u7 equals to ar raised to power 6. And of course, from the question, ar squared u3 is 48 and ar raised to power 6 u7 is 3. Call this equation 1, equation 2. Now we need to find a and r, because before we can find the 12th term. So doing that, we divide equation 1 by 2. So ar6 over ar squared equals to 3 over 48. So if this cancels this, we have 3 here, 1, 16. So u3 ar squared. Okay, let's see what is wrong here. So r raised to power 3 equals to 1 over 16, but we can't find the cube root of 16. We can't find the cube root of 16, so r equals to cube root of 16, which does not exist. So then u12 will be ar raised to power 12 minus 1, 11. Okay, so that will give us a. We've not gotten a. Let's take a. So a equal to using the first this equation 2, we have 3 roots 1 over 16 raised to power 6 equals to 3. See, and of course this is 1 over 16 raised to power 1 over 3 times 6 over 1 equals to 3. So 3 here 1, 3 here 2. So a times 1 over 16 squared equals to 3. So a into 1 over 16 times 16, which is 16 times 16, it is 256 equals to 3. So if we cross multiply, we have a equals to 3 times 256, which is 3 times 6, 18, 3 times 5, 15 plus 1, 16 carry 1, 3 times 2, 6 plus 1, 7. So a is 768, and then u12 equals to ar raised to power 11, which is 768 of r cube root of 1/16 raised to power 11. So, and this will give us 768 into 1/16 raised to power 11/3. Okay, and if we can simplify that further, it will be good. 1 divided by 16 equals to raised to power 11/3, which is this, multiplied by 768, and to certain decimal places we have 0.0295. So three significant figures. Okay, so this is how far we can go with the question. The next question. The third term and the fourth term of a geometric progression are 5 and -20 respectively. Find the first term and the common ratio. So let us try to decompose this. Solution. The third term and the fourth term, write down the general formula ar raised to power n minus 1. So u3 equals to ar squared and u4 equals to ar cubed. Okay, so ar squared equal to 5 and ar cubed equal to -20. We call this equation 1, we call this equation 2. So finding the common ratio, we divide equation 2 by equation 1, and we have ar3 over ar squared. We cancel it, this cancel this, we have 1 equals to -20 over 5, this 5 here, and -4. So therefore r equals to -4. And using equation 1, we can find a into -4 squared equals to 5, a multiplied by 16 equals to 5, and a equals to 5/16. And then we have that. Find the first term and the common ratio and the ninth term. So the common ratio is r, the first term is this, and the ninth term, when n equals to 9, we have u9 equals to ar raised to power 8. So we can find the ninth term to be ar raised to power 8 equal to a, which is 5/16, multiplied by r, which is -4 raised to power 8. Okay, and this is of course 5/4 raised to power 2 multiplied by this, -4 raised to power 8. Minus raised to power 8 is positive, guys. So this is 5 times 4 raised to power -2 times 4 raised to power 8, which is 5 multiplied by 4 raised to power -2 plus 8, which is 5 times 4 raised to power 6. And with the help of calculator, 4 raised to power 6 is 4096 times 5. So the final answer here is 20,480, guys. 20,480. Well, we are done with the question. So see you in the next video, which is geometric mean. Please remember to subscribe so you know when we drop the video. Bye.